Thank you, Chairman. Thank you all so much for being here. This is an important discussion for us to be having. Fusion energy certainly is a very important research area that has the potential to completely transform our energy sector. It also has a massive undertaking that is emblematic of the internationalization of major research facilities. Our scientific communities have to work together because we can no longer just go it alone and expect to get anything done. Dr. Bigot, I wonder if I could address my first question to you. First, I want to say that I really appreciate the work that you're doing, and from all that I've heard, the ITER project seems to be in a much better place than it has been in the past, and I think much of that is because of your leadership. One question I'd like to ask you, and I hope you can be candid so that we can help to make America a better partner. I wanted to ask what the biggest hurdles that you face or that others face for working with the United States. What are the first questions you ask yourself when we say that we're going to deliver on a project that is 5 or 10 or 15 years down the road?
As you know, this project is so large that just one single country could not afford. You have to think about that we are building huge magnetic cages. The size of it is 20 meters, I would say, with a precision which is millimetric. So if we are just considering one country, whatever powerful it could be, it will be too long to clearly demonstrate. So for me, it's very important, again, as I stress the point, that the US be committed on the long term and could contribute. They contribute with their staff, as I mentioned. They could contribute also for many other technologies. Okay, the project, the ITER project, as any others, okay, fusion project, request a lot of different technology, cryogenics, electrotechnics, materials, and all these things. And so all this part could be gathered, okay, and I expect, as it was told by Dr. Prager and Dr. Shu, that there is strong support for all this basic research which could contribute to accelerate the proper delivery of the fusion technology in the world in the very next decades, really.
Thank you. Yeah, I do see how important this partnership is, and I hope we can remain a reliable partner. That's something that we've got to struggle with and make sure that, especially the funding side of things, that we are reliable there. Dr. Prager, I wanted to talk briefly with you. First of all, it's good to see you again, and look forward to seeing you later with the lab day that's going on over on the Senate side this afternoon. But the privilege I have of representing Fermilab, I see a lot of similarities between our two labs being single purpose, and I'll make sure that any measure of success our labs use takes into account the differences between these labs and also our broader multi-purpose labs like Argonne and some others. When we do science, the science itself should always be the driver of the work we pursue, but it's always good for us to know the other side benefits and application from our research. I wonder what other applications does your research have that can benefit the nation?
Thank you, and I do want to thank you for your broad support of the whole National Laboratory Complex, which is invaluable to us.
Thanks.
The applications of fusion energy science go far and broad, and there are two classes of applications. One is to other areas of science, and the other one is applications to society and industry in general. In science, we only have to know that essentially all of the visible universe is made up of plasma. So if you want to understand how stars are formed, how black holes work, why solar flares occur, if you want to understand the space weather in the Earth's environment, that's largely a problem in plasma physics. And the synergy between fusion science and what we call plasma astrophysics is enormous. So the effect on astronomy is enormous. Regard to one of your interest areas of Fermilab, there are plasma ideas to build new accelerators where you can accelerate particles much more quickly to high energy over much shorter distances than the present accelerator technology. And this is a very exciting application of plasma physics to particle physics, which is the focus of Fermilab. In industry, plasmas have a nice property. They're kind of people-sized and they're pretty hot, and you can use them to interact with materials in revolutionary ways. So plasmas are used to make semiconductor chips and have in part fueled Moore's law. Plasmas are used to make new types of nanostructures that are revolutionizing various types of industry. Plasmas are used to burn up waste. There's a new area of plasma medicine where plasmas interact with biological systems. You can use plasmas to heal wounds, and plasmas can affect chemical reactions in biological systems. There are plasma rocket thrusters that are in use today. You can, instead of having a chemical rocket, you can shoot a plasma out of a nozzle and the rocket moves forward. So you can have rockets that are much more fuel efficient. So there's a remarkably broad array of both fundamental science and industrial applications of plasmas.
That's great. Sounds exciting, and looking forward to everything that comes out of this. Thank you all again. My time's expired. I yield back, Chairman. Thank you.